Hello folks, welcome back. In this video tutorial we will try and simulate a chiller plant using Process Simulator Pro 2. This chiller plant is actually a very small part of a larger natural gas processing unit. This video tutorial is very simple and it is meant for people who want to get started with Pro 2. It is also meant for college students who are excited about process simulation and want to develop further interest and explore this powerful process simulation tool. And it is also for those people who are anyway interested in process simulation. Let me tell you one particular thing at the very outset. These video tutorials that you would see on my channel on YouTube are meant for academic use only. There is no commercial interest implied, either directly or indirectly. So please do not get into any such business. It's purely for academic use and nothing more than that. Alright, I like process simulation and therefore I make these videos. Otherwise there's no other agenda behind this. Alright, so the various data and the equipment that we would be using in this simulation are indicated in the Word file that you can see on your screen. I will read out the problem statement for you and will also take you through the data and information that is supplied and we would be using in this simulation. What you basically have is a gas stream which has various components: nitrogen, carbon dioxide, methane, ethane, propane, butane, isobutane, pentane, isopentane, and C6 plus petroleum component. The percentage moles of each of these components is given to you as shown in the table which is visible on your screen. The total flow feed rate is also given to you as 4 into 10 to the power 7 saturated vapor feet cube per day. The temperature and pressure of the feed stream is supplied to you, 120 degree Fahrenheit and 250 psi gauge. For the C6 petro component, you need API gravity. American Petroleum Institute gravity is 73 and the NBP, the normal boiling point, is given as 210 degree Fahrenheit. The equipment that we would be using comprises of a scrubber which is modeled as a flash drum. The temperature and pressure are 85 degree Fahrenheit and 203 psig. We would be using a single stage compressor, centrifugal compressor, which gives a discharge pressure of 600 psig and has an adiabatic efficiency of 72%. We would be using a cooler where the hot side is a process stream and the outlet temperature is 105 degree Fahrenheit and delta P of 5 psi. The cold side is the utility heat, which in this case is air, and the inlet outlet temperatures are given as 80 degree and 100 degree Fahrenheit respectively. Additionally, we would be using a pump which gives a discharge pressure of 550 psi gauge with an efficiency of 65%, and we would be using another drum which again is modeled as a flash drum with no duty and no pressure drop. Alright, so I'll just take you through this Word file once again to give you an idea of what the problem is all about and what we are going to do in the next few minutes. Alright, so we would be using Pro 2 as the process simulator in this particular case. It would be interesting if you have access to other process simulators. You can try and simulate this particular unit in that simulator and try and compare the results and see the difference in the similarities. Alright, so once you have access to any process simulator, in this particular case Pro 2, the first step that you need to do is start the process simulator. Alright, so just like any other program, you need to go to the start button and then click the icon for that particular program. In this case it's Pro 2, so we would start the process simulator. So this is the icon for Pro 2. If you double click on this, wait for a few seconds, a window such as the one visible on your screen would open up. It will take some time to load completely. You need to wait for that, wait until that. Okay, once that has happened, you would see a screen with a gray background and a small message box at the bottom. If you want, you can close this. Now this is what a normal Pro 2 screen would look like when you just start your program. Right now, since you want to start a new simulation, you need to go to the simulation environment. So whenever you want to start a new simulation, you should click on this button on the extreme right side of the toolbar. If you click on this, a new simulation environment would open up, as you will see. Alright, so the color of this background can be changed according to your preference. It is absolutely insignificant and has nothing to do with your end result of simulation. Alright, so once you get to this point, the next step is to draw the process flow diagram. That is how the process flows from one unit to the other unit. Alright, so Pro 2, like any other process simulator, has a bunch of unit operations, alright, which are included in what is known as a PFD palette. This palette that we will see shortly has all the unit operation and equipment that are commonly encountered in a process industry, and you would be using some or all of these during the course of your simulation. Alright, so to get to the the PFD palette, you need to click on this button on the toolbar. If you click once, an elongated small window would pop up, as you can see on the right hand side of your computer screen. Alright, as is clearly visible, I'll just scroll down this palette just to show you the different equipments that are available and the different things that you can do with this. It has a compressor, it has a fired heater, it has an LNG heat exchanger, it has a flash drum, a mixer, a splitter, a distillation column, a side column, almost everything that you want while simulating a part of a plant or the whole plant. Alright, so the first step, as I said, is to draw the process flow diagram. In this particular case, before you start your simulation, you should know the process flow diagram, meaning you should know the flow of process fluid from the starting point to the end point. Alright, so before you do that, you should also be familiar, or you should know exactly the equipment that you would be using for your simulation. In this particular case, as we said, we would be using a scrubber which is modeled as a flash drum. So you need to just click on this icon and drop it here. So this becomes your scrubber. Then we said we need a compressor. Just scroll down this palette, PFD palette. You see an icon for a compressor. Click on it once and drop it here. Alright, next we said that we need a cooler. Alright, as you can see, a simple heat exchanger here icon. Just click on it once and drop it here. Right, then we said that we need a pump. Alright, so if you just scroll down a little, okay, pump is here, just click on it and drop it here. And then we said we need a final knockout part, which is again modeled as a flash drum. Just scroll up a bit, click on it, drop it here. So these are the different equipment that we would be using in this simulation. Alright, so the next stage or the next step in your simulation is to connect the various equipment that you have placed on your simulation screen. Alright, we actually do not, okay, now this red bordered button with streams written on it, you need to, these equipment can be connected by flow streams, which you can get by clicking on this button. Alright, so we have a feed stream which is coming to your the scrubber. The scrubber, what it does, it separates the gaseous feed stream into the vapor part and the liquid part. The vapor part goes to the compressor and the liquid is pumped through a pump to some different unit. Alright, so again go to this stream button, click on it and attach it or connect it to the compressor as shown. The discharge of the compressor is fed. The discharge of the compressor is fed to this cooler. So you connect the cooler head to the compressor head like this. The discharge or the output of the cooler head is fed to this knockout drum, so you connect the drum to the cooler head in this fashion. And then for the knockout drum you have a vapor head component and you have a liquid coming out of it, right? Fine. The initial scrubber is, has a liquid head product which is connected here to the pump in this fashion. So this completes the PFD for this particular simulation. It looks very simple, and we want it to be simple because we are just starting. Later on, as you gain experience and familiarity with various different features of this process simulator, you can simulate any complicated process plant that you want to, provided you have sufficient data. Alright, so we have drawn the PFD or the process flow diagram, as you can see. So this is the first stage or the first step towards simulating any process unit. Alright, so we don't need the palette now, we can close it. If you need the palette, PFD palette, you just need to click on this button and it would appear again. Alright, for the time being we don't need, so we can close this. As you can see here, the icons are looking very small. If you want, you can zoom in using this button and zoom out using the other button. Alright, so now these are the different equipment and the streams, as you can see on your screen. The next stage is to provide the feed components, right? The different components that are used. The component hits can be supplied by selecting this component selection button, which is a benzene ring with a red boundary. If you click on this, a window would open up. Alright, so in order to feed the component, you need to hit the selection button and then go to the most commonly used, select most commonly used option. Now Pro2 gives you the option of selecting the component either by their full name or by a chemical formula name or by scientific simulation name, anything. I prefer full name. So we have nitrogen. I just type in nitrogen. I see nitrogen here. To add nitrogen, just hit this button, you get nitrogen added, right? Next is carbon dioxide. Just write carbon or carbon dioxide, part of the name or the full name, select it, hit the button, you get this. Next is methane. Select, add component, then it's ethane. Again, either you write the full name or you write the first few letters. Then you have propane. Select it, hit it. Then we have butane, which is normal butane. Alright, then we have isobutane. Then we have normal pentane. Alright, you would find that you're not able to pentane. You need to just scroll down a little. Okay, there we go. Right, so select pentane and add to it. Then you need to add isopentane. Okay, you're not able to get. Okay, so it's isopentane here, add to it. Then we have the other component that we have is, okay, so we have added pentane, isopentane, normal pentane, and the last component is C6+. To get to C6+, okay, that's a petroleum component. So once you have added all these commonly used hydrocarbons, just click OK. Select the petroleum button from here and just feed in the data. Alright, if you observe, you're provided information about the C6 plus hydrocarbon petrol component, the API gravity, and the normal boiling point. Out of these 3 fields, you need to supply at least 2. So the normal boiling point is given as how much? It's given as 210 degree Fahrenheit, and the API gravity is 73. So we will feed the data. Boiling point is 210 degree Fahrenheit, and the API gravity is 73. Right? You can give the name, whatever name you want to. Molecular weight is not necessary. If you know the molecular weight, it's well and good. Click the OK button and you're done. Right? So you have added all the different components. Right? Next is to press the OK button. Done. So now what you have done is you have added the components. The next step is to select the component properties. Click on this button and then select fixed properties. Alright, as you can see, the various data is already collected. Just click on this. You need to supply temperature dependent properties. You don't need this. Then let's cancel this a little. Sorry, you need to put the thermodynamic data. For the thermodynamic data, you can use the equation of state, right, and select Peng-Robinson. Okay, the primary method you need to select and select the Peng-Robinson. Alright, then you need to go to the modify button and select the transport properties as this. Alright, petroleum correlation and liquid deficit matter. Okay, rest of the things you don't need to add, and just click on this OK button. You're done. Further, if you click on this, you're done. So what you have done is added the components and added the thermodynamic property that you would be using, right? Next step would be is to feed in the stream data. All right, so you should select composition defined flow, and this you're given a total flow rate of okay, note that the default unit here is pound mole per hour, but the unit that is given to you in the data is saturated vapor feet cube per day. So locally you can change the unit by selecting the UOM button, which stands for unit of measurement. So you are given a vapor volume feet cube per day. Change units, done. The volume that is given to you is 4 into 7. All right, the nitrogen percentage mole is given to you as how much? 1. Right, you can use the tab button to go down the table. 1.6. just feed in the data. For methane it is 72.5, right? For ethane it is 11.5. all right, 6.75. then we have how much? 1.25. then we have 3. Butane is okay, butane is 3, isobutane is 1.5. so this is 3, this is 1.25. all right, pentane is the normal pentane, which is 1.1, and isopentane is how much? It's about 0.55. The normal boiling point, or the C plus 6 plus component, is 0.75, right? It should add up to 100. Why it is not adding up to 100? Just a minute. Okay, it's adding up to 100. Fine. All right, so once you have added this, press the OK button and you're done. The thermal condition, say its temperature, which is given to you as 120 degree Fahrenheit. The second specification is pressure, which is given to you as how much? 250 psig. See, here it is psi absolute, so locally you need to go and change the unit. All right, that's fine. So what you have now done is supplied all the information about this stream. It has every information. Next, what you need to do is now go and supply the information for the rest of the units, right? So if you click on the flash drum, you are given information about this scrubber. The temperature is 85 degree and pressure is 203 psig. All right, so pressure is given to you as this. So pressure is how much? 203. Right. Second specification is temperature, which is given to you as how much? 85 degree Fahrenheit. All right, this is fine. Okay, so click on it. All right, the next is your compressor. The inlet pressure is not known to us, is not given, I think. We're given a discharge pressure and adiabatic efficiency. So the discharge pressure is given to you as 600 psi G. Sorry, the discharge pressure is given to you as 600. Okay, again you need to locally change the unit, right? 600 G. Thermal adiabatic efficiency is given to you as 72%. All right, so once you input all this information, you need to click OK. So you've supplied the minimal information for the compressor. Next is the heat exchanger. Select the process side. It's a hot stream. All right, click OK. I think all right, so the pressure drop thermodynamic system is the default. You're given the hot side is this, the outlet temperature is given to you as 105 and delta B of 5. Pressure drop is given to you as how much? How much is the pressure drop? It's about 5 psi. All right, and specification, the hot product temperature is given to you as how much? 105. All right, click OK. Similarly, the cold side you need to select select the utilities air. The inlet temperature is 80 degree and outlet is 100, so just input this information as such, click OK, you're done. Alright, so click OK on this as well. Right, the last piece of information that you need to supply is regarding the pump. So hit on the pump icon. Okay, we missed one thing. We did not add the product stream to this pump, so go to the palette button, select the stream from here and show the pump discharge as this. Now the PFT is complete. Alright, you can close this again. Alright, so now to input the pump data you need a discharge pressure. Okay, so you can collect on this. The outlet pressure button you can select and put the value as 550. See the unit once again, it is 550 psig, so you need to locally change the unit of this discharge pressure to G. Right, the efficiency is given as 65, so make it 65 and then click OK. Right, and the last thing that you want to add is information about this knockout drum. The pressure drop is given as 0 and the unit specification is duty, which is given as 0 in this case. Alright, is this fine? Click OK and you are done. Now what we have done is added all the information that Pro2 needs for calculating the various streams, various information about, I mean, it has all the necessary information that it needs. What you would have observed in the beginning, some of these boxes were colored red. Now the color has changed to black. It tells you that Pro2 now has the minimum information it needs for doing all the necessary calculation. Right, once you are done with with input of all the different and relevant data, you need to go and run your simulation. Right, one big mistake that we have made is not saved our simulation, so you should first go and save your simulation. Alright, so take it, save it wherever you want to. You can give it whatever name you want to give. You can save it as a simulation PR. Let's say we give it as a chiller 1. Alright, so your simulation is now saved with a particular name. Now you can go ahead and run your simulation. There is this button on the toolbar is the run button. The moment you click the run button, you would see the color of these process equipment or the icons on the process flow diagram sheet would change color and would become blue. Right, you'll see this in a moment. The moment it happened very fast, and so you will not be able to see the intermediate colors. Actually it will change color from green to blue. Right, so your simulation is over. Pro2 has done the necessary calculation. On the bottom you can see on the left hand side it says problem solution reached. Right, now you can get the summary report. If you want to if you want to see the result, just double click on it, just right click on this icon and select the option view results. A window would pop out. Just wait for some time. Okay, giving you the various calculations it did and the input data. Alright, likewise for every other equipment you can get the similar view result option. Right, you can get the entire result in the form of an Excel sheet by selecting the generate Excel output button from the toolbar. If you do it, you need to wait for a few seconds and another window would pop out. Just wait for some time. It's just compiling the data in the Excel format. Alright, so this is all about, this is just the basics of Pro 2. We would in the subsequent video tutorials see more complicated processes, and we will try and simulate them. It may not be possible to simulate the entire plant at one go. You will have to break it into different sections. There is a concept of multiple flow sheets in Pro 2. We will try and utilize that when we do some some complicated plants. All right, we will wait until that time. All right, so thanks for watching this video. I hope it will be useful for the student community as well as to all the practicing engineers, and including those who want to get started, who are working and want to try their hands at the process simulation. So this is the Excel sheet that would open up if you select that option. All the different results are compiled in this one single sheet. It makes it very easier to scan and review the result when it is put in this format. All right, the entire solution history is also obtained. All right, so this is the various calculations it did, and gives you all the data. All right, let's close this. Thanks friends for watching this video. Hope it will help you help you inspire, and will make your life interesting. That's all. Happy. Good night.